All right. So let's take a look at this pattern and see if we can figure out what's going on. What do we notice? What do we notice about this pattern? Yeah, it's adding a little extra guy on the end each time. So this one got these new pieces. This one got this one, this one, this one, and this one. So how many is it adding each time? Four. It's adding 4, it's adding 4. This one started with 5. This one has 9. This one has 13. So how could we figure out what pattern number 15 is going to have? I don't want to have to draw 15 of these. How can I figure it out without having to draw all 15? Yeah. So a common way that I've seen people notice this is that we've got one set of 4 right here, and it's staying here. It's still here. And then we get our second set of 4 here, which is again here. And then we get a third set of 4 here. So this has one group of 4. This one has 2 groups of 4. This one has 3 groups of 4. So when it comes to pattern number 15, how many sets of 4 is it going to have? 15 sets of 4. Times 4. And then we've got that loose guy in the middle. The one piece I didn't highlight or mark on was this guy in the middle. So that little guy needs to be added in. So we're going to have our 15 times 4 plus 1. So pattern 15 has what? How many? What is 15 sets of 4 and one more? 61. What if I didn't tell you which pattern number? How could we write like an expression for it? What if I wanted pattern number 30 or pattern number 47? We're taking our pattern number times however many sets of 4, and then we added 1. There are lots of ways to notice this pattern. There's lots of different ways to find it. The sets of 4 on this pattern tends to be the way most people see it. But if you spotted it a different way, that's totally fine. This pattern recognition stuff is basically push-ups for your brain. As we're going through stuff, we're going to start noticing in patterns and things that we're working with. And if all we do is sit here and stare at me doing stuff, you're not actually using the muscle. You're not doing the push-ups. You are watching me do push-ups. Which, as much as I wish that counted as exercise, it don't count. So if you just blankly follow along while I do this, and you stare off in space, kind of like this. If you go to class and it looks like this, you're not thinking anything. This is a thinking activity. Are we okay? No dying, please. It's way too much paperwork.
I am CPR certified.
So am I. Please don't make me have to use it. Gosh, the amount of paperwork involved. Okay. Questions about this pattern? Because shock of all shocks, we're going to do something else about the pattern. Oh my gosh, what? Relevant. Oh, we are going to be in our workbooks. Oh my god.
I can give you a pattern. Triangle, square, star, triangle, square.
It feels like you're trying to do the Konami code on PlayStation. Are you done now? Okay.
Oh, wait, yeah.
I was going to say, it works very much like a cough drop. It's just close to giving you a cough drop. Thanks. I was going to say, it's close as I can go to giving out cough drops. Cough drops are medicated. They're almost the same. sometimes it just got a little sugar. Okay, we're gonna be on pages 63 and 64 in your workbook. I do recommend opening it like this because we're gonna have times when we're looking at both pages. And if we get stuck, we're gonna look over here. If we get stuck over here, we're gonna look over here. So we're going side by side. Doing it like this. Because what we have here is we have 3 lovely patterns and a very large grid at the bottom. I want you to draw pattern number 4. I give you 1, 2, and 3. Draw pattern number 4.
Oh,
I recommend, and actually you need to use pencil because I'd say more than half of us are going to get it wrong at once. And I don't want you to color it in super dark. Like you can color it in. Color it in is totally fine, but don't just like color it in because you might have to erase it.
so we're shading.
Shade as necessary. You do not have to shade it in. If you just draw the boxes, that's totally okay. Something in here I don't have smudge. I don't have a sample.
What? Coffee? No, it's not that. It's just, I don't even know.
It's a drawing in this building and we're allergic to school.
That's
I can't
no,
open
because
this.
it's actually not the only guy you want to.
Yeah. I'm just going to, I'm very intentionally don't bring scented items. I don't wear perfume. Like, I try and make it so that my room is not one of the places you go, ugh, sensory overload. Yes, dear. Take a whole box. Like I say, it's just like a snippet of graph paper. Think of that graph like I came up to you guys with going, oh shoot, I wish you had graph paper. And I went, just like this. Oh yeah, I have a piece. So it's just a segment of graph paper. Nice graph paper. Oh, my rulers are floating. Yeah, my rulers. Your brain. Oh, it's in the time window. It's in the time window. Huzzah. Whoa. Huh? I didn't say we'd have to. I said we might have to. If you get stuck on the pattern, start looking at this table. Go back and forth if we need to. We're going to try and draw our pattern, and we're going to fill in this table at the top. So if you get stuck on the pattern, go back and forth. Well, we have great power to make our choose. We have to make sure that we don't all parts of the patch. Okay? All kinds of stuff on this pattern. Lots of pieces, lots of pieces. I'll go back over to patterns 1, 2, and 3. I was like, you guys can talk to each other. That's fine with me. Work together. Talk it through. See what we can come up with. We need pattern number 4, and we want to try and fill in this table. Let's look at the top table.
Table?
On the next page. We're going to want them open side by side because it's going to be easier to look at them both ways. Mhm. Go. See what we can come up with. We're going to start talking through a little bit of them here in just a couple minutes. I want to give you guys a chance to think it through. All right, what do we notice about these 3 patterns? There's lots of things we can notice, but what is one of the things we noticed? Because we had to notice some things in order to draw the next part of it. Say it louder, because I'm old, I couldn't hear you. What goes up by 1? Yeah, we got these little corners. I've got a 1 here. This guy has 2. Bless you. This guy has 2 here. This guy has 3 here and here. So we know wherever these corners are, it's going up by 1. So on pattern number 4, we know it's going to have 4. I'm just going to pick a spot. 1, 2, 3, 4. And it's going 1, 2, 3, 4. So it's kind of shaped like this in the corner. What else do we notice about these patterns? What else do we notice? So here we've got 5 little white squares. Here we have 7 little white squares. Oh, yeah, 7 little white squares. And over here we had 3. I was just in the middle one. There we go. So the middle squares are going up by 2 this time, whereas each of these side squares was going up by 1. So this guy's going up by 2 to get to 7. So that means on pattern number 4, how many over do we need to go? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's when we get our other 4x4 piece. 1, 2, 3, 4. So they give us more graph paper than we need. There's wiggle room around the outside of it. So we need to make sure we're being careful and intentional and counting. Notice all the parts of the pattern. 2, 3, 4, 5, 6, 7, 8, 9. Because it should be more like this. So whenever we're looking at sketches or we're trying to figure a piece out, color a piece in, we cannot assume they give us the exact right size piece of paper. I wish we could, but we cannot, because our pattern should actually look like this. It doesn't go quite all the way to the edge. And then we have this inside part, which will also have gray tiles. But we just need to be really careful because this should be 9. Yes, 9. Okay, just make sure. And these are each going to be 4. Ooh, that paint does not show up there. There we go, that's 4. So our pattern should look a lot more like this. So let's look at this little table that we've got going on here and see what that's all about and why the heck we care there. So this is, or questions on the pattern number 4 or anything like that. So we're gonna look at pattern 1, which is already filled in that table. They counted out our gray squares versus our white squares. And on pattern number 2, we can come through and we can count our gray squares or our white squares. They've already counted out the number of gray square or white squares here as 40. So see if we can figure out the number of gray squares in pattern 2 and the total number of squares, blocks, cubes, whatever we call them. Total number of pieces in pattern number 2. We need the total number of squares and the total number of gray squares. So looking at pattern number 2 over here. And that's when it is probably going to be helpful to have your page open like this, where you can see both. There we go. And you can count them. You can see if we notice patterns on things, all that stuff. See what we've got. We need the total number of blocks and the total number of gray blocks. Oh, sorry. Put this over here. There we go. What do we think? How many blocks are there in pattern number 2? I would say either the total altogether or the total number of gray blocks. Either way. Find me one of these for this guy. Yeah, we've got 41 gray blocks. They've already counted up that we have 40 white blocks. So how many total blocks are there in pattern number 2? 81. Because we have 40 white blocks. We have 41 gray blocks for a total of 81. It's kind of annoying having to try and count all of them. Ew, gross, right? I see down here, we wind up with 25 total blocks, and we've got 81 total blocks. How many total blocks are there going to be in pattern number 3? How many total blocks are along the side of pattern number 1 here? How many tall is this? 1, 2, 3, 4, 5, right? This is 5 blocks high by 5 blocks across, which is why it gets 25 blocks. And our pattern number 2 is 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks. by 9 blocks, which is why it has 81. So how many tall is pattern number 3? It's 13. So this one is going to be 13 by 13. So there are how many squares in this one? 169. Because we noticed that I could just count up my 5 by 5, my 9 by 9, my 13 by 13. What about these? What do we notice is happening with our white blocks and our gray blocks in here? I'm gonna zoom it in. I just looked at these bits. What do we notice about these two pairs of numbers, 12 and 13 and 40, 41? Say it louder. Yeah, they're one away from each other. 12 and 13, right next to each other. 40, 41, they're one away from each other. They also add up to be our total. So 12 and 13, one away from each other and add up to be 25. 40 and 41 add up to each other, or one away from each other and add up to be 81. So what numbers might we get if we have the same kind of pattern for 169? How could I figure out what two numbers are one away from each other and out to be 169? 84 and 85. How do we figure that out? Divide it by 2. 169 divided by 2 gives you 84.5. So if you round down, you get the white blocks. You round up, you get the gray blocks. Or you can take away 1 so that you don't get decimals because, ew, gross. But that's for pattern number 3 over here. If I came through and I counted up my 9 squares here, my 9 squares here, my 9 squares here, my 9 squares here, and all these ones in the middle, we are going to get exactly these numbers. So sometimes we use our pattern recognition in different ways. Below here on question number 2, it's asking what we noticed about the white blocks and the gray blocks. That is 100% what we were just saying. They're one away from each other. Oops, changing the page. Ah, there we go. My screen changed. Fixed it. It's back. Okay. They're one away is the way that you guys were wording it from each other. I have very little space up here, but you guys have more space. However you word it is up to you. As long as you can conveying your thoughts, I'm fine with that. So they're trying to help us out here on this next part in 3A, trying to help us spot a pattern that we've already started to notice. And that was that we had our 5 times 5 that gave us our 25. 81 we got from our 9 by 9. So if we're looking over here on 3A, it's talking about how 25 came from 5 squared. 81 comes from us doing our 9 squared. 169 came from our 13 squared. And if we look at our pattern number 4, how tall was it? Should not be 20. Make sure we're counting them. Watch out for this middle piece. That we followed the pattern. Some of them are a little too big. We should have wound up with a pattern that was 4 and then 9 and then 4. So 4 plus 9 plus 4 is 17. Oh, shock. Look what they have here. 17 squared. Gives us 289. So how many squares are in our whole pattern number 4? 289. Because this one came from our 5 squared. This one came from our 9 squared. This one came from our 13 squared. And what's happening between these numbers? What did they do with these base numbers? How did we get from 5 to 9 to 13? We add 4. I heard it. It was quiet, but it was there. We're adding 4. Adding 4. So if I was to add 4 to get to our 17 here, 17 squared is what's giving us the total number of squares. So how many white blocks are we going to need for pattern number 4? Or how many white blocks did we use? 144. Divide it in half, round up. Which means that the number of gray blocks is going to be 1 more, 145. So we didn't have to come through and count all these squares. We didn't even have to find areas of each of these shaded in parts to add them together. We could have. If I wanted to do 4 times 4, add those all up, find this area, add them up. It works. We should get the same answer. But we don't have to do that if we can start to notice these patterns. So the next thing they're asking us is how many blocks would pattern number 5 need? What would the next one be? So they took the 5, and added 4. We took the 9 and added 4. So if I wanted to know what my next piece was, I would take my 17 and I would add 4 to get 21, and then we would square it. That is impossible to read. Hold on, I'm gonna rewrite that. So we would have our 21 that we needed to square to get our total number of squares. And 21 squared, you can type it in a calculator. We should get, right, with a different color than yellow, 441 squares. So what if I go, well, we need to be able to repeat this pattern in different sizes, all kinds of over the place. So I want to be able to just put the number in. I want to be able to just put in a pattern n, like the way we can do on this one, where we had our n times 4 plus 1. So we want to see if we can figure out how many blocks pattern n would need. But wait, we see a whole lot of really familiar numbers. Look at this. We've got 5 leading to 9, leading to 13. So we had 5. That led to 9. That led to 13. Did we already find part of this pattern? Oh my gosh, what relevance is she? This is the pattern for this part of the number. This is a part of the pattern we've been looking at. So this guy right here, n times 4 plus 1, is how we can get this bottom piece. It's the base number we had here. So these numbers inside that circle I drew, if I wanted to do this for any n at all, whether I wanted the first one, the third one, or the 500th, we can get with our n times 4, which I'm going to write as 4n plus 1. That gives us these guys, our base numbers here. My 5, my 9, my 13, my 21. Whatever's being added is what we're multiplying by here. That's where those pieces are coming in. First one here is what would happen if we had n of 1. 4 times n plus 1 gave us 5. But we're looking to find these numbers. So we took our base and we squared it. So what we're going to do is we're going to take this base and square it. So if I wanted to find any number at all of tiles, I could take my 4n plus 1 and square it, and that would work for absolutely any number. We're going to work practicing a lot on how to build these equations. They are very rarely going to be this complicated. This one's kind of gross, which is part of the reason, oh my gosh, why we did something like this. To see these numbers in a way that was a little clearer to find the pattern. So sometimes we're going to look at other patterns in order to find our pattern. So I want you guys to think about the next two. Look at 4A and B. think about how you would do this. How would you make an expression for just the number of white blocks? Or just the number of gray blocks? And part B is if number 6 had 625 blocks, which it would according to the equation, how many white blocks would you need? So look at those and see what you guys can come up with. See what you think. Again, this is one of those things that we have to actually do the thinking part, because the thinking part is the muscle. Got to use the muscle. So think through those. See what we can come up with. How could we write something down for those? Tailbone's going numb sitting on the table. I think 4B is probably a little easier to get the actual number on. So how many white blocks would pattern number 6 need? 312. How'd you get that? $625, and we divide it by 2, and then we round down. So whatever number we have for our total, you can divide by 2 and round down. That would get you the number of white blocks. You could divide by 2 and round up to get the number of gray blocks. That would totally work. That would explain how we're doing this. If you really want it to be super mathy without it being a thing, you could just subtract 1, so divide 624 by 2. All that does is make it not decimally. Totally works. Take 625 divided by 2, round down, and we've got that. Because what we're doing to get the number of white blocks is we're taking the total number, dividing by 2. It's dividing it in half and rounding down. So I know sometimes when we work through these activities, they're weird, and I ask you stuff in a weird order or to look at something in a weird way. I know, it's part of it is the point, part of it is the curriculum. But the whole point in doing these activities is to actually do the thinking part. This is the muscle you're trying to exercise. If you come in here and just watch me do stuff, or stare blankly at the screen while we listen to the podcast playing in our ear because we're not actually paying attention at all and we're just staring off into space, you are effectively watching basketball on TV, showing up to the game and saying, "Start me, coach. I'm ready. I watched a game on TV. I'm ready to play basketball." You've got to actually use the muscles and do the drills, practice stuff. Otherwise, you're showing up to test day going, "Start me, coach," and he goes, "Who are you? I've never seen you before." It's like, "Yeah, I watched a basketball game on TV. I'm ready to go." That doesn't work. I wish it did. Trust me, I wish it did. You've got to actually do the thinking part. So I know we get annoyed waiting for me sometimes. It's okay. We're relearning how to do this. That's what this class is all about, is to learn how to do the mathematical thinking part. And so I know it's uncomfortable sometimes, but that's what we're here for. Okay? So, that's all I have for you today. You have 8 minutes, so it's not going to be a ton of time. It's 8 minutes. Our chapter test is next Friday. I know. We will get through page 76 by then. We are on 64 right now. So we've got about less than 10 pages, because some of them are repetitive. Got a couple pages of dot. We've got some distribution practice. We're gonna look about distribution. We're gonna look at some stories. We're gonna do all kinds of stuff.